Do you remember what the derivative of e to the x is? Good, nice job. We're on a good start today so far. So, therefore, we have the integral of e to the x dx is equal to e to the x plus a constant. Does anybody here know the antiderivative? I'm sorry, anybody here know the derivative of b to the x? So suppose it's not e, suppose it's like 3 to the x. Yep, b to the x times natural log of b. So therefore the integral of b to the x dx is equal to b to the x divided by the natural log of b plus constant. Anybody know what the derivative of natural log of x is? 1 over x. So therefore we say that the integral of 1 over x dx is equal to the natural logarithm of x plus c. And those will be the basic ones that we look at. There's a couple more we can add, but I don't think that they actually come up on the AP test, so we'll leave them for a later time within this unit. So we're going to evaluate the following. We have, I think I rewrote this problem to be 9.5. Is that correct? Very good. So I've got a 9 here. We've got 5 here. We want to determine the value of the integral from 5 to 9 of 2 over x minus 3 dx. So what we would like to be able to do is find antiderivatives of kind of complicated expressions today. What I'm going to do is I'm simply going to say that u is equal to x minus 3. So what is du? Just 1, right? The derivative of x minus 3 is 1, so I just have dx. I don't have a dx. I have 2 dx. Yep. So 2 du equal to 2 dx. So I have 2 times the integral of 1 over u du. We'll deal with the bounds in a little bit. What is the antiderivative of 1 over u? Natural log of u, yeah. So I get 2 times the natural log of u. What is u? X minus 3. And we are going to evaluate that at 9 and 5. I plug in 9. What do you get? Minus 2 times. And we can simplify that. I'm going to see if you guys remember this. I'm worried that you will not. But we good? All right. So as I look at this, I'm going to factor out the 2. I have 2 times natural log of 6 minus the natural log of 2. Does anybody out there remember what I do when I'm subtracting logarithmic expressions? I divide them. It's 2 times the natural log of 6 divided by 2. 6, yep, 2 natural log of 3. You could write it like that, or you could write it as natural log of 9. Yep. So maybe you also remember that if you have a number in front, you could put that up to the exponent. Do you remember your laws of logarithms? It's an opportunity for you to go back and rethink those a little bit. So, well, I've got the 2, right? So the 2 dx I replace with 2 du. We said that 2 du is 2 dx, right? So the 2 is gone. And what do I put in place of x minus 3? U, so I have 1 over u. Nope. Either one of these would be acceptable. All right, letter B. Anybody want to guess what u is in this situation? E to the x minus 1. So u is equal to e to the x minus 1. So what is du? Isn't that nice? Therefore, we have the integral of 1 over u du. What is the antiderivative of 1 over u? So I get the natural log of, what is u? E to the x minus 1. And I'm going to evaluate that at what? 4 and 2. If you wanted to, you could. I didn't because if you remember, if we have a u there, we technically shouldn't use 2 and 4. Remember that? Okay, so we'll just leave it off. All right, so I plug in the 4, and I get the natural log of e to the 4th minus 1 minus e squared minus 1. Hey, I'm subtracting them. So instead of subtracting, I can divide. So this is the natural log of e to the 4th minus 1 over e squared minus 1. Really? Chris sees something awesome. He sees that the top factors, it's the difference of squares. So e to the 4th minus 1 factors 2. E squared minus 1 and e squared plus 1. So you see the e squared minus 1s will cancel, leaving us with the natural log of e squared plus 1. Thank you, Riley, for your input today. We were waiting for you to chime on in. You have impeccable timing, as many people would say. Okay. Let's do it. Say tomorrow. Let's roll. Getting a couple people shaking their heads. All right. So how about letter C? Anybody, anywhere. Not a definite integral this time, indefinite. What about x squared? Very good. U is equal to x squared. Here's why we choose u to be x squared. Because when you take the derivative, what do you get? 2x dx. So see how I come up with that x? So that's good news. We don't have the 3, though, do we? So how do we come up with the 3? 3 over 2 du is equal to 3x dx. We're not going to worry about it. Three over 2 integral. What do I put in place of the 3x dx? Just 3 halves du. And d Weiland is correct. What remains? 5 to the u. So the question is, do we know the antiderivative of 5 to the u? Yeah, we do. The antiderivative of 5 to the u is 5 to the u divided by a natural log of 5 plus a constant. What is u? So therefore, we have 3 times 5 to the x squared over 2 natural log of 5 plus a constant. Sure. No. you can only do that with a logarithm. So if you had, say, the natural log of x squared, then you get to dump the 2 out in front, but not unless there's a logarithm involved. We cannot simply just take the expression x squared and dump that out front. Must be a logarithm involved. So I saw the 3 here, so I'm like, let's multiply by 3, and let's get rid of 2 by dividing by 2. We don't for the other ones because those were definite integrals, meaning they had bounds, so we come up with an actual number. Whereas in this one, it is indefinite. Anybody want to take a guess at a gander of what we want u to be for letter D? Very good, natural log of x. So u is equal to the natural log of x. What is du? Not yet. I don't have a 1 over x dx. I have a 1 over 4x dx. So what are you going to do? By a fourth. So 1/4 du is equal to 1 over 4x dx. 1 over 4 integral du u squared. Very good. So D. Weiland, when you get in that situation, first put in your 1/4 du and get rid of the 1 over 4x dx, and look at what you have left. You have u squared. You see it? Take time to cross it off, and there it's right in front of you. Well, I have a, yep, times it by a fourth because I had 4 in the denominator. Oh, what's the antiderivative of u squared? So if we multiply by a fourth, we get, what is u? U is the natural log of x. So we have the natural log of x cubed divided by 12 plus c. That's our antiderivative. Not easy problems, are they? Okay, a couple more call a day. Letter E and F are actually really, really easy problems. However, people fight them and resist them. I'm sorry, I'm going to try to do my best to appease to your brain, but there are no guarantees in this situation. Does anybody know our approach that we take for letter E? As I have one term in the denominator, I'm going to divide everything by x and simply rewrite the expression. I therefore have the integral of, what is 3x squared divided by x? 3x. What is 4x divided by x? What is minus 2 over x? So I just rewrote it. I haven't done any calculus at this point. I just divided it. Pre-calculus. Algebra. Math. Oh, boy. All right. So let's take the antiderivative now. What's the antiderivative of 3x? What's the antiderivative of 4? What's the antiderivative of 2 over x? What's the antiderivative of 1 over x? All right, let's help Gigi out here. Gigi, what's the derivative of natural log of x? Right? So therefore, the antiderivative of 1 over x is natural log of x. So what you're doing in your brain is you're saying, well, 1 over x is x to the negative 1. So what I'm going to do is I'm going to increase the exponent by 1, and I'll divide by the new exponent. And that's the expression you get. So that's why we can't do our normal power rule for 1 over x. Rather, the antiderivative is 1 over x. If you'd like to see the proof for that, come see me after school. Kind of a nice little trick, huh? Dividing things works out. And the fact is for letter F, this is where people really fall apart. But the fact is I remember, guys, do you remember when we went through this again? They're sitting in a calculus 2 class, and we're doing a challenging integral. And I said, you guys, here's a great method that works a lot. And you just take the bottom and divide it into the numerator. We came up with a new expression. So see if this connects for where you guys were at. But you can use substitution here. It gets kind of icky through the process. I'm just going to say, let's take x minus 1, and let's divide it into x plus 1. All right? What do you multiply x by to get x? 1. So everybody okay with that? So therefore, I have x minus 1. Subtract x minus x. I get 2. So we have a remainder of 2. Agreed? I will try once more for you. And then I'm going to have to say that you'll have to come in at some other time in order to get caught up on it. So I'm going to take x squared plus 3x minus 7, and I'm going to divide it by x plus 1. Okay? So we're going to do a long division problem. This is something we've done before. We take x plus 1, and we divide it into x squared plus 3x minus 7. What do you multiply x by to get x squared? So we put the x here. We multiply back through. What do you get? Subtract, and you get 2x. Drop the 7. What do you multiply x by to get 2x? 2. Multiply through. 2x plus 2. Subtract, and you get negative 9. So the remainder is negative 9. So we have minus 9 over the divisor, x plus 1. Or maybe you would prefer to see it like this. Negative 1 box, 1, 3, negative 7. Boom, drop it. 1, negative 1. 2, negative 2, negative 9. So we get x plus 2 minus 9 over x plus 1. Yeah. The long I'm going to tell you guys that as you move forward in calculus 2, there are many times where the long division becomes more useful than the synthetic. So you need to see the long division without a doubt. Okay, you're going to have to come back to that. Okay, here we go. Back up. So I have the integral of 1 plus 2 over x minus 1 dx. So I just rewrote the expression. Now let's make it easy. What's the antiderivative of 1? X plus, uh-oh, looks like I should use substitution for that, right? What is u? U is x minus 1. What is du? Dx. I don't have a dx. I have 2, so I go 2 du is equal to 2 dx. So I would just have, I'm just focusing on the 2 over x minus 1. So then I have the integral, or 2 du, and what's left? 1 over u. What's the antiderivative of 1 over u? Yeah, so you can see I get 2 over, whoop, I'm sorry. So you can see I get 2 times the natural log of x minus 1. Where? So, again, so Carter, Jake, and you don't need to agree with me. I guess maybe you feel differently, but weren't there a number of situations where simply using the division created the problem to be easier. Yep. Definitely a step that you want to be able to take. So I have some basic examples in your assignment where carrying out long division would help you. Because I already did the 1. What's the answer of 1? X. So let's be done with that. So you can always take integrals and break them up using addition and subtraction. So I took care of the 1 first, set it aside, and I took care of the next piece. Okay. Ready for an easier problem? What do you want u to be here? Close. 3 plus cosine of x. What is du? Very good. We have a positive sine of x dx, so I multiply by a negative. I get negative du is equal to sine of x dx. You know, that's a really tricky question. I don't know how you would divide that. Like if I try to take 3 plus cosine of x going into sine of x, that's not written as a polynomial, is it? Yeah, so that's why I said from the beginning, if you would like to set up for this one, u is equal to x minus 1 and do a substitution there, you can. It will work out the same. It takes longer. The answer looks differently, but it is the same, and that's definitely an option you can use. But I highly encourage you guys to do the division, because all I need to do is this. X squared plus x plus 1 divided by x minus 1, and all of a sudden, you will not want to use substitution anymore. You will say, I want to do long division. It is a good thing to be able to do. Trust me. All right, so we've got this guy. I've got the negative, and I've got the du. Negative integral du 1 over u. What's the antiderivative of 1 over u? Natural log of u. So I've got negative natural log of 3 plus cosine of x plus c. Last problem. What do you want u to be? Square root of x minus 2. Very good. Good morning. Thank you so much. What is du? One over 2 roots of x dx. What up, dog? Yep. I am. I would love it if I had a microphone around my neck with a speaker up there so I could record the lessons. But I don't know. That's not me at this time. Avery, why don't you go see the big guy? I wasn't commenting about your height. I was commenting about, like, your prestige. No, never. I wouldn't go that direction. Okay. Multiply by, not by 2, by 1/2. 1 over 2 du is equal to 1 over 4 roots of x dx. We there? All right, so I have 1/2 integral. I've got a du e to the u. Look at how easy the integral becomes. What's the antiderivative of e to the u? So I get 1/2 e to the plus a constant. Isn't math awesome? If you don't have the constant, I take a 1/2 point off every time, and I scream as I jam the spoon into my eye and dig it out of the socket. Yes. Yeah. Yeah, so each problem on your test yesterday is worth 5 points. So I'm going to look for bounds. I'm going to look for the proper setup. Like if you don't have a setup that's appropriate, like let's say it's a disk method, but you set up a cylindrical shell, like the -3 is going to come out pretty quickly on that one right there. Yeah, take a point off. Yeah, I think I'm a pretty fair grader when it comes to tests. I've had people who felt otherwise in the past, and I invite them to come on and sit down. We can look at it together, but they never show up. So